going to be live. Hopefully we're live now. Hey everyone, welcome to the virtual star party for June 14th, 2020. We've got an interesting night tonight. Not sure how this is going to roll. The OPT telescope in Landers, beautiful, dark skies, no moon. It was going to be the perfect night, no wind, but we can't seem to make the observatory door open remotely. So unfortunately, no luck using the RASA. But we've got two telescopes tonight. So we've got, let's see. So we've got, with telescopes, we've got Roy Salisbury. Hey, Roy.
Hey.
Blending into the starry background there. And you've got good dark skies, but here's what I don't understand. You picked up new camera gear for your telescope, and somehow your telescope is functional. Like, where are the clouds? Where are the thunderstorms that are centered on your observatory going out to, miles around?
First light was last night. It was perfect, and it's supposed to be perfect all week.
Yeah. So I think something horrible is going to happen tonight.
Yeah, no kidding.
Yeah. You're going to see like lightning storms striking your telescope. Man. I don't know what it is. Normally astronomers, we're a skeptical bunch. We're a science-oriented bunch, but there's something about the superstition of buying a new telescope that just runs deep, I think.
Yeah.
So we've also got Linda Thomas-Fowler, who is in just outside Washington, D.C. And Linda, you've got nice clear skies.
Well, clearish.
Sucker holes.
It's actually yesterday it was supposed to be cloudy, and tonight it seems to be clear, but there seem to be right on the edge of clouds. So things could change at any moment, but right now it looks good.
Good. Okay. All right. And then Stuart, you've got high clouds, so you just figured you'd join and give us some targets and hang out for some conversation.
Peanut gallery, yes.
Yeah, exactly. Awesome. The funny thing is, it's so much easier when we do these star parties and I'm not actually operating a telescope. I can just focus all my energy on explaining the sky and answering your questions. So actually, it's probably a better show when I'm not trying to also run a telescope, but then we don't get as many nice pictures. But anyway, but we'll go for like an hour or so and see what we can see. Each week, of course, the sky moves another little bit as it moves through the seasons. And so some of the objects that we were having trouble reaching last week, hopefully we're going to have a much easier time this week, especially because Linda is about 3 hours into the future. So we should be able to get some interesting objects that we haven't seen since we started up the star parties again. Let's get rolling. Linda, you've got a long, like a long duration observation you've been doing on M101. Is that right?
That's right. Let me share here. And this is how long? 44 minutes on M101 through a blue filter. I actually have my mono camera on tonight because I've actually been capturing these images for a long-term M101 project that I'm working on. So trying to get about 24 hours total.
Wow.
And so this is 44 minutes of blue that have been live stacked here while we've been waiting. So I'll end up stopping this here in a moment so we can move on to other things.
But you'll set
that
aside and keep going. Can you explain this process though? So you are gathering, you're doing like one really long exposure image of M101, but you're taking a bunch of separate images in a bunch of separate wavelengths, right?
Right. So this software is actually doing the capturing, and you can see right now it's on the blue filter, and down here it's doing dithering right now, so it's not exposing, but it's doing 1 minute exposure. So we're getting to 24 hours, 1 minute at a time.
Wow.
Wow. Now, why do you
That's a
do a
long
1
time.
minute exposure? Couldn't you do a longer exposure?
It's a combination of two different things. One is the amount of sky glow we have here in the DC metro area, and the other is the amount of dynamic range on the camera. So the ASI 1600 being a 12-bit camera doesn't have that much dynamic range.
Hmm.
And so it's better to stack up a bunch of shorter exposures than one longer exposure, because you end up clipping all the stars
Right. Right.
and losing all the star color. So the payment for that is doing some really, really long processing at the other end when you have thousands of files.
And so do you just find, just through trial and error, you've learned what's the right exposure time for every
Yeah,
object
there
that
are
you want to look at?
there are some formulas that you can use to try to kind of figure out what that is. And in my case, it works out to about at this particular gain 25, which is fairly low gain on that camera. It works out to 1 minute, actually slightly less than 1 minute, but I just rounded up to make my life easier.
I mean, I
Now,
found that my experience was whatever was the longest exposure I could run before the stars started to blob up into like overexpose. And
That's what I do as well.
yeah, because I want
I
the
just sort
stars
of
to
see.
look like nice little stars and not big overexposed blobs.
yeah, and with let me flip back to this one here so you get a better picture. But while if I do that, I actually have an image on Astrobin where I did that of the Dumbbell Nebula, and the stars just turn into pure white nastiness. Of course, I really overexposed that when I was at the beginning when I thought I knew what I was doing and didn't. Now I don't think I know what I'm doing and still don't. But but that seems to work out pretty well for broadband here. Now for narrowband, with 3 nanometer narrowband filters, I have to do 5-minute exposures, and even then I'm still kind of barely getting enough light. So it's
Yeah,
amazing how much light those narrowband filters block.
yeah. And
And
so
it just shows how much more. I mean, my narrow band images are usually about 20. I do 20-minute subs for my narrow bands.
Yeah.
and so the each like this is just the same image, and so every minute is just adding more data to the picture to
Right.
make it look have a little more data and a little less noise, and only in the blue.
This is just blue. Yeah.
Yeah.
And it's live stacking.
Mm-hmm.
Yeah. So just to give people some context here, that's M101, right?
M101. Yeah.
Yeah. Okay. So still
And
we're in galaxy season still, but this is a great, very high object right now. So we're looking at here's Ursa Major, which is of course the Big Dipper, and the handle of the Dipper, and just sort of forming a triangle with the final two stars of the Big Dipper's handle, you get M101, the pinwheel. There's actually a bunch of other objects in the area, but M101, they're all associated. So all these other NGC numbers are associated, I believe, or are they background galaxies? I thought they're like star clusters in M101.
I'm not actually sure myself.
Yeah, yeah. I know for some, like with Andromeda, there's a bunch of other NGC objects that that connect with the actual and with the Andromeda galaxy.
Yeah, like I think M30.
Well, that's a whole separate.
M30,
Yeah, that's a whole separate galaxy. But there's
M32.
actually like regions in Andromeda that have been identified, and they have their own NGC objects.
Gotcha. Yeah. And M33 is like that as well. And you can actually see some of them in even the little 80 millimeter telescopes pictures.
Yeah.
If you want, I can run the live stack from beginning to end. I don't know how well that shows up on the video here, but
it depends how quick it goes. But it'd be interesting to see how quickly it sort of how it improves the quality. I mean, it's interesting. I find that it tends to be good in the beginning, like it gets pretty good pretty quickly, and then. But yes, you can see all the noise, and so this is you running an animation of it improving. You can see
you can see with each step the noise is going down and the signal's popping out more.
Yeah. That's pretty amazing. I mean, that live stack looks terrific.
Yeah, that's a nice demonstration of signal
Yeah, it
noise. Yeah, and how signal, goes up to the
Yeah.
square of the noise.
Then so when you do a longer exposure, you're getting more just overall stuff into the sensor. It's those multiple images that you take that your program starts to figure out what is signal and what's noise. But I'd say like right there, I'm not sure how long that is where you're at right now. That's pretty good. Like it's clearly
Yeah.
like diminishing returns.
Shaw's come
Once
in.
Yeah.
Sorry. I just saw
Shaw's
Shaw.
here.
Hi, Shaw.
Yeah. He's got Venus.
Yeah.
J Venus. And Shaw, I hear the sun has one spot. Oh, we can't hear you yet.
Can't hear you yet, Shaw.
Can he hear us? Does he know where he is?
He looks a little lost.
He does look a little lost. Yeah, yeah. We'll let him get his bearings here.
Is he still 3 degrees from the sun?
Yeah, I think it's.
Hey.
There
Hey,
you
Shaw.
go. There you go.
Sorry, I'm late.
Yeah.
No
It's okay.
problem. You slept in.
Yeah, it's pretty small at the moment, and can you hear me?
Yeah, we can
Yeah.
hear you.
All right. So I got Venus over here.
Did you want to
Let me
share your screen?
share. It's really hot.
Let's see.
You should tell people where Shaw is.
Yeah,
Because
Shaw,
they may
you're
not know.
you're in Malaysia, right? Just outside Kuala Lumpur.
All right. Here's Venus now. I think it's a bit. I think it's a bit far away. I think.
That looks good. So, how far away is it from the sun now? Because I know you were breaking your own personal records. I'm assuming you lost it in the glare, and now because it looks like it's sort of passing over the sun now.
Yeah, but I think now it's a bit far away. I think it's about maybe about yes, a few days back was about 8 degrees. Now it should be around 10, 11 degrees away.
Okay.
Yeah, so it's a bit. It's
Oh,
Clouds.
Throw out all those frames when you do your stack. So, if people remember, a couple of weeks ago, Shaw was here and he was showing us Venus as it was closing in. It was still the evening star, but it was getting closer and closer and closer to the sun. And of course, like you can look at his background there. He's in the middle of broad daylight right now, getting images of the sun, and that's what you have to do if you want to get Venus when it's really close to the sun. And the risk, of course, is that he fries his whole telescope system, lights the top of his house on fire. So be safe, man. I think you got clouds now. Roy, how's your image going?
Not as good as I hoped.
Uh-oh, what? Did we jinx it?
Roy, just drive out there, change the camera out, and then join the party
Change it
again.
back.
Yeah.
I'll share what I've got so far, but because I'm not binning the color images, and I can't stretch it for some reason. I've got it shared there if you want to look at it.
Okay, we'll take a look here.
It's very dim.
That's the Edge-On Galaxy?
Yeah, that's the splinter.
Right. And how long of an exposure is that?
So far 4 minutes. So it's actually live stacking as well.
Oh, it's live stacking as well.
Yeah, I was
Yeah.
doing 2-minute images. So 6 minutes here in just a second. There's 6 minutes.
And were you doing a bin?
No, it's not binned at all. This is the first time I've ever done one-shot color. I don't know what binning does.
Like in general?
I think the same
I
thing.
know what binning does in general, but I mean on a one-shot
this
color,
one.
does it still come out color?
It does on the ASI 294.
Okay, then I'll switch it.
Oh, good. Okay. So we have, someone mentioned we've got a big crowd of people over on Twitch. Yeah, we definitely do. Right on. Yeah, okay.
I have another live stack I can run for you.
Yeah, let's do it. And then we'll come back and check out Venus.
This is the Leo triplet that I was also working on earlier tonight. And now it's behind a tree for me. So I got not quite an hour on this. Oh, live stacking is, why are you unhappy with me? Clear that. And here we go.
So that's M64, M65, and some NGC. I can't remember what it is.
Yeah, yeah. I mean, I appreciate you rotating the...
It's to the correct orientation.
Yeah, to the correct orientation so we can see the face.
Yeah.
I think it's really important. Yeah. So,
we're astronomers. We're easily amused.
yeah, exactly. That's funny. Hey, all the people on
M65,
Twitch.
M66, and NGC 3628.
Yeah, yeah. Are they in any way gravitationally... So I'll show people sort of where these are.
Yeah, so they're about 35 million light years away.
Yeah.
And I can't find if they're gravitationally linked or not.
Yeah, so you got the... So
This is
two
too bad.
large galaxies, the Leo triplet, and then I think it's the Hamburger... The Hamburger galaxy is the other part to it.
Yeah.
Yeah. So
again, this is blue data.
Yeah. To all the people who are raging on Twitch, sorry, this is being simulcast on YouTube from YouTube, so we actually aren't running a Twitch channel. It's just that people at CosmoQuest are duplicating what we're doing. So anyway, so hello, I hope you're enjoying this. These are the virtual star parties. We do these every Sunday night as soon as it gets dark on the West Coast. We have as many telescopes live streaming from around the world as we can. Today we've got 3 telescopes, 2 in the US and 1 in Malaysia viewing Venus during the daytime. So there you go. And if you're interested, we do this, like I said, every week. Okay, so let's go back. Shaw, how's your Venus?
It's a bit cloudy at the moment. It's already past the meridian, so I have to change the scope.
Oh, you're doing a
side.
flip.
Yeah, I have to do a flip. But
So-
at the moment, I'm sharing the view of the comet Lemon yesterday. The C2019 U6 comet Lemon.
Yeah,
It's,
this is the new one, right?
It's fairly new.
Yeah.
But it's really bright because it's about magnitude 6.
Yeah.
So this was taken yesterday evening, about an hour of exposures, combination of 16 frames, so you can see the comet moves among the stars. So it's really cool.
Yeah, yeah. That's really cool. That's really cool. I mean, up until this point, we've been getting images of, I think, pan stars. But I think you were saying on Twitter that this is really bright.
This is the one. The comet Lemon was brighter than Pan Star. Pan Star was about magnitude, I think about 9 or 8.5.
Yeah. So is this
this?
But this isn't going to be the bright comet that we're all due.
Yeah, they were expecting Pan Star to be much brighter, but
Yeah.
apparently the Lemon is stealing the show now. But it's a bit low. It's near Canis Major, I think. So during sunset, it's already about 25 degrees in the west. So I have to rush the imaging session a bit.
Yeah. That's really cool. So how many exposures did you do here?
This is I think about 16 exposures, each about a minute, 30 seconds, around that time. I can't remember. I can't recall exactly the settings, but there are about 16 frames, starting about 8 at night till about 9, about 1 hour.
Mm-hmm.
So I combine them, I stack, and I think I've posted a photo of the combined image
You
to
did.
see the tail much clearer on Twitter just now, this morning.
Yeah. Can you
So-
share the picture here so we can see it?
Yeah. Share it over. Let me see if I can find my
Do the
way
inverted
around.
one too. I like the inverted one.
Yeah. Let's see.
So if anyone on Twitch, I do see the chat. So if you have some questions about how to take pictures of space, telescopes, by all means,
All right. So this is the one.
pop out chat. Go.
It's a black and white
There we
image. The one is the inverted image. So the inverted one is much clearer. I think you can see the tail stretch a bit towards the upper right.
Oh, hold on.
Frame.
I think Linda's get the Ring Nebula going, but I'll come back to you, Shaw, here. Hold on.
Oh.
Yeah. Okay.
Oh, go ahead. We've got a longer exposure running.
Okay. Great. That's cool. So what is the value? Like, why do you do the inverted image?
Well, people say that for inverted image, we can actually see much clearer compared to the white star. You can actually see if the stars are black or the object is darker, we can actually see much detail in it.
Yeah.
But in a way, it does seems logic because you can see the tail much clearer on the inverted image compared to the normal one. Yeah.
It's interesting though. So in this case, you directed your telescope at the comet, and then did a longer exposure, and you can see the stars are trailing because the comet is moving, right?
Well, no, actually, because I did an individual exposure each, maybe about 30 seconds or 1 minute, and I fix inside the software for stacking, but I focus it on the comet, so it is comet alignment.
Yeah, there's a common alignment process in PixInsight, and you can do two. You can do a star alignment and comet alignment, and then mesh it. But he didn't do that. He just did it on the comet.
Right, but I'm saying by taking different exposures of the comet, you're actually getting the stars. Like the comet is moving, right?
Correct.
Yeah.
Right.
Yeah.
I tried taking the comet about 2 minutes exposure, but you can see the comet trail in the single image, so it doesn't look nice. So I just have to keep it short, 30 seconds, maybe 1 minute, and stack those image. Yeah.
So Kevin is asking on Twitch, what kind of telescopes are we using to capture all these images? So we've all gotten very familiar with this question. So Shaw, what's your telescope?
Okay, can you see my telescope here? Or
we can see it behind you.
All right. Okay. All right. So I'm using the the dark one is a Skywatcher 120 ED. It's a focal length 900 mm, and the shorter one is the TS65Q with a focal length 420 mm.
Right.
So the comet images I use the shorter one. So the CCD is over here. You can see it. It's an old QHY9 CCD, black and white. For the planetary images, I use the longer focal length.
Yeah.
And I got another scope over there behind the Celestron.
Yeah. Oh, so that's not the one. Yeah, that's the one that's pointed at Venus right now.
Yeah. So you can see there's an extended shade by the top, just in case the sun has some ideas and shining the lights into the scope. Yeah.
So someone was asking, when would you be able to see Uranus? And unfortunately, Uranus is down below the horizon right now, so you'd have to be able to look directly through the ground. I don't know what time it rises.
And Roy's scope may be big enough to capture it. But,
yeah.
Linda's and mine would not be.
But Shaw, you've gotten pictures of Uranus before, right?
I think only once. I think.
Yeah.
It doesn't look nice.
Yeah. Well, it looks like a. Oh, there we go. Yeah. So it's in the daytime is when you have to be able to look at it.
I did manage to get Mercury, Venus, Mars, Jupiter, and Saturn in daytime. But I don't think we can get Uranus magnitude 5 in daytime.
Yeah. So unfortunately, you need someone. We need it to move into the nighttime sky. So Linda's got M57, which is the Ring Nebula.
60 seconds of luminance here.
Yeah.
And we're trying an oxygen 3 frame to see how that compares, which should be done in another 2 minutes.
Yep.
But this is such a bright object that it's easy to see. It's just really small.
Yeah.
If I shrink this frame down, you can see it's really quite small compared to the frame.
Yeah. And so this is a planetary nebula. So this is the expanding cloud of gas and dust that was sloughed off from a star, kind of like the sun, but about 5 billion years older than our sun is. And so as it was going through its final stages, puffed out into a red giant star, blasted out all of these outer layers into space, and they sort of expanded out into space. And so you're left with this sort of final, and in the picture, I don't know if you can see it, but there's actually a central star, which is the white dwarf star, the dead leftover star after the star itself died. And we see a bunch of these in the sky. There's probably a few dozen of these planetary nebulae that we can see over the course of the year.
And this is, I have an up an image that I'm cheating. I took last week, but I didn't get to share last week, so I'm sharing it now.
Oh, sure, okay.
And this is also the ring, and this is 2 minutes of luminance bin 2x2. And if we zoom in on it, you can see the binning, how it's all. So this is what happens when you're binning. So people were asking last week, what does binning do? And it increases your sensitivity, but you can't zoom in because you get this pixelation.
Someone's asking if I like Kurzgesagt. If you actually look at my channel on YouTube, my avatar is a Kurzgesagt image of me. I wrote a script for one of their videos about black holes. So how long, when you're taking images of the Ring Nebula, what kind of exposures do you like to do, Stuart?
Well, this one was just
like that
2 minutes.
A little overblown.
If I'm right, well, that's just because I was auto stretching it, and I just did a quick auto stretch. I mean, if I can, I can go back to here. If you go back to me, you can see how, if I turn off the auto stretch, this is what it normally looks like. This is not auto stretch, so it's you can see it like that.
And there you go. Thad is saying 1,500 planetary nebulae are known in total in our galaxy, but many are too faint to see with backyard scopes. That's amazing.
Yeah. So if I'm imaging this for real, I would probably bin 1. I would probably do 10-minute LRGB images, because and with the caveat that I just have to watch the stars, make sure that I'm not getting saturation, but I usually don't, unless I'm doing like a star cluster or something like that.
And so binning is this process where you essentially take multiple pixels on your camera's sensor and merge them together and take the average of what's falling on the different pixels.
Right.
And it lets you take an image faster, but not at the same kind of resolution. And so imagine, you take a picture with your digital camera and you get 1/4 the megapixels on your camera, but you get a much faster picture, which is what we want as astronomers.
It's a common technique. I don't do it, but a lot of people do, where they'll do non-binned luminance images, and they'll bin their color. For basically to save time. I don't do that, but others do, and it's currently a valid technique.
Yeah, I don't do it either. I don't think it makes as much sense for the CMOS cameras as it did for the CCD.
Yeah, I found with the telescope, with the RASA, binning just made it worse. Raising the gain made it worse. I just found no gain, no bin was the way to go.
Yeah, that telescope is so fast, you probably don't need much gain.
Yeah. Just Vigley is asking, is there not a robot or automated system for helps recognize the different objects? I mean, the way it works is we know the objects that we're going to be observing. The telescopes themselves have a mount that directs automatically at the object that you're looking for. So it's more like you say, I want to see the Ring Nebula, and the telescope moves over and directs at that target. So it's not like we don't know what we're looking at in the screen. It's the hard part is like getting the thing that you want just in the screen in the first place.
Yeah, and there are easier ways to do that nowadays, where what I'll do is I'll download an image from Astrobin.
Yeah.
It's plate solved, and I'll just tell my telescope, take that. And it searches around till it finds that exact image, and then it'll go, oh, that's nice.
This is 2 minutes of oxygen on the Ring Nebula, so you can see it's pretty bright when you.
So can you zoom
filter
in
it that way? That's as.
Is that as zoomed as it'll go?
That's as.
Oh no, you got more.
Yeah, I mean we're past 1:1 now, but yeah.
Oh sure, that's fine.
All right, Fraser.
You ready? Okay.
I went to a backup plan, but.
Ha! Oh, that looks amazing. Wait.
Oh, nice.
You're using one of your older telescopes?
No, it's this scope. I've just downloaded it locally. I can't figure out how to stretch it on the other one.
Oh, so even that like 70 megabyte image?
No, it's actually, since it's been 2x2, it ended up being 30 megs.
So that comes
it takes
quicker.
5 minutes to download from my observatory.
Right. Yeah. So you get a little bit ahead of it.
Processing power.
Yeah. Amanda Scholl is asking, so Shaw, do you have like some way to block the sun so you don't fry your setup?
Yes, the one. It's a cheap one.
So hold on. So wait a second. So what do you do to protect your telescope?
I just extended the dew shield of the scope. As long as I can get. And basically that's it, and hope for the best.
Right. Like in theory, right? If it's pointing at Venus, then it won't be pointing at the sun.
Yeah. But the trick is because it's daytime, so my scope needs to do the alignment first.
Yeah.
So I have to put the solar filter and align with the sun first, and then I slew to Venus. So since now Venus is about maybe 10 degrees, 11 degrees away from the sun.
Yeah.
So it's at a safe distance. So I don't really have to worry much about the sunlight spilling in. But I still use the extended dew shield just in case.
And Chad, is your mount good enough that you can just center on the sun and then just slew to Venus and it's right there? Or do you have to hunt for it?
At the moment, I need to hunt for it a bit because it's going way further from the sun. But when it was near the inferior conjunction the other day, a few weeks back, so it's very easy. It's just point to the sun and point to Venus, and it's there in the field of view. So,
so what is the object that you've got, Roy?
That one is that's the Splinter.
The Splinter. Do you know the NGC number on it?
I got it.
Oh, the Splinter Galaxy. Okay, I got it.
I think it's 4565. Is that same thing? Splinter, needle.
Yeah, no, I've got it. Yeah, it's 5906.
Oh.
Yeah, so.
Needle and splinter, I think, are two different things.
Oh, are they? Okay. So this is above the constellation of Draco. So before, remember, we were looking at M101, which is just at the end of the Big Dipper, and then where Roy's pointing now is where this little spot is, and that is the Splinter Galaxy. And this is great. So this is a galaxy you're seeing edge on. So this is a big spiral galaxy like the Milky Way, but you're actually seeing the galaxy sideways. And so you're seeing this central core here. This is the core of the galaxy, and you're seeing the dust lanes, and you're seeing the arms, the spiral arms, but you're seeing them from the side. And you're seeing the blobs, the star-forming regions in the spiral arms, but we're seeing them from the side. Amazing. Fantastic work. And it looks like there's you've got another little galaxy up behind it there.
Just to the right and up.
Yeah. And I'm sure there's a bunch of them. I mean, that whole region is so filled with.
I zoomed in a little bit. Let's just come out some.
Yeah. WKU fan 89 is asking, does the incidental light from the sky not overpower Venus?
Nope. Venus is really bright.
Yeah.
Because it's bright because the light is not really spread out. It's just at the thin edge of a shape, the crescent shape. So it's really, really bright. So it's easy. In fact, you can actually see it with the naked eye if you know exactly where it is. But of course, you don't do it now because it's still too near the sun. So we have to wait maybe about 40 degrees, 45 degrees away from the sun. So much safer. But Venus is very easy in daytime.
Yeah.
So
and that's a trick. You can try that. If you do know where Venus is going to be, and you can use a program like I'm using Stellarium, and so you can just do a search for Venus. And right now Venus is below the ground. But if you know when Venus is going to be up, right, I'll just move time forward here. So, whoa, that's so trippy. Okay, so there's Venus during the day. And you can see how it is, some amount, I guess, about 20 degrees, say, away from the sun. So if you know where to look, you can go and put yourself in a shadow, like in the shadow of the house. And then you can look at the right part of the sky, and you can actually see the dot in the middle of the daytime. But it's tricky. You gotta practice, and you gotta be careful, right? Because you definitely don't want to look at the sun, and don't use. I mean, it's better if you use like a pair of binoculars or a telescope or something. But again, we always are so nervous about telling anyone to look at anything with a telescope in the daytime because you zap your eyes.
I rarely see Venus through the telescope in the daytime, so it's too scary. Actually, it's too dangerous.
Yeah, exactly.
I'd rather like the camera burn itself rather than my eye.
Yeah, exactly. Roy, you got another object for us here. Yep.
This is 60 seconds.
This is a 60-second M13.
Yes.
Oh, that's beautiful. Oh, that is really terrific. I think you figured this out. I think you got this working. Yeah.
It's a little green. I think it just needs more stacking.
Yeah.
And I just got to figure out
fine.
How to adjust the colors.
Yeah, it's fine. So again, this is M13, probably the nicest globular cluster that we have in the northern hemisphere. They've got a much better one called the Omega cluster in the southern hemisphere, which is even bigger and brighter and more stars and closer. But this one is terrific. It's very easy to spot. I like to it's pretty much if you know your sky. I'll show you where M13 is. It's so easy to find.
I was looking at Omega Centauri last night. Let me show you the.
Oh, so you can see Omega Centauri from your location?
Yep.
So
really
this is the constellation of Hercules, and a way to find it. If you go out tonight, like now, the pretty much the brightest star that you're going to see in the sky is called Vega, And that's this guy here. And this is part of the summer triangle. There's 3 bright stars in the summer triangle. Again, if you go, no matter where you live in dark skies, bright skies, if you can see no clouds in the sky, you can actually see the summer triangle. It's these 3 stars, Vega, Deneb, and Altair. And so near Vega, which is the brightest of these 3, is the constellation of Hercules. And you can see the chest of Hercules here, and it's in between these 2 stars. And with a small pair of binoculars, you can see them. Titus 6 is asking, is this done by hobbyists, or is this some part of a larger project? No, they're all hobbyists. Each of these people has their own telescope, and they are sharing their view from their own personal telescope. So, Shaw, I'm looking at your screen right now. You were talking about Omega Centauri. So that is one impressive globular cluster.
Yeah. It's huge. It's a lot of stars. I mean, there's one shot. I don't have it at the moment. I just did 1 second exposure. Right? You can actually see almost something like this. So it's
that's
really
a 1 second exposure.
No, this is I think about 30 seconds.
30 seconds. Okay, yeah.
Yeah. Say, wow.
Yeah, yeah. Well, I mean, I don't know. Like, I wouldn't be surprised, right? You could probably get a pretty good shot even with a 1 second exposure. It's such a bright object.
Yeah. But M22 in Sagittarius, I think that cluster looks much more photogenic compared to Omega Centauri from my point of view. It looks more 3-dimensional thing shape like that.
Yeah.
But I don't have the photo at the moment. And behind this is Eta Carina.
Wow! Again, these are things we just don't get to see from the northern hemisphere.
Yeah.
Oh, that's amazing.
Let me try to.
So Eta Carina, this is the star. People, remember when Betelgeuse brightened up and everyone was so excited that Betelgeuse was going to explode. But this is the star that's most likely to explode in the near future. This is the one that looks like it's going to go any day now. So which one is it? Is it that bright star right in the middle?
I think it's the one in the bubble. I think over here.
Oh, okay.
Yeah. I think this is the one somewhere inside there.
Okay.
Yeah.
And so it's a star with I think somewhere around 50 plus times the mass of the sun, and so it's going to explode again any day, anytime between now and in the next 100,000 years or so. And when it does, it will be bright in the sky. Well, to the southern hemisphere anyway, not for us in the north. So you've sort of at the sweet spot. You've got a view to both the southern end. So can you see the large and small Magellanic Clouds from where you live?
It's a bit too low for me. It's still, I think, about 20 degrees above the southern horizon. That's the highest point. I couldn't see it with the naked eye from Kuala Lumpur, but some of my friends, they managed to see it from the darker spot.
Yeah.
It's a bit too low. But I still get one of the best spot, the Centaurus, the Scorpio, the Sagittarius, or that stretch. There's so many clusters, so many nebulas over there. So really nice. I just need the color CCD.
Yes. Yeah. Yeah. But that's amazing. Oh, congratulations.
Oh, jeez.
Yeah, I wish I could see it.
I am liking this camera now.
Oh, okay. You got another picture for us.
I'm saving it right now. I think you're going to like it.
All right. But I do like the Omega. It was great. When I was in Australia about a year and a half ago, I had mentioned in the talk that I gave that I'd never seen Omega Centauri, and so they were doing a star party, and so everybody had their telescopes set up. Actually, Shaw was there. We hung out for a bit.
Yeah.
It was so great, and there's so many. Everyone had their telescopes pointed at Omega Centauri, and like, Fraser, come check out our telescope. It was awesome. But the thing that they don't get in the southern hemisphere is they don't get all these great galaxies. So they do have some of the best objects, but they don't get the galaxies. So, but Shaw, you're right in the middle. You get it all. You get the galaxies. You get some of these southern objects.
Yeah.
So Shaw, you're right near the equator, right?
Yeah, about 3 degrees.
Mm.
Like, yeah, at the equator, yeah.
Yeah, I mean, we need Paul Stewart in New Zealand to really show us the
we gotta find Paul again. We'll get him.
All right, Fraser.
Okay, you ready? All right.
Yep.
Wow.
3 minutes.
That's a 3-minute exposure on M51.
Yep.
That's amazing.
Very nice.
Oh, congratulations. Yeah, I think you've found your sweetheart camera here.
Takes me a while to figure it out, but yeah, I mean, and you can even see there's a galaxy up here. There's a galaxy up here.
Yeah. Yeah, you can see there's a whole bunch of galaxies. So this is M51, also known as the Whirlpool. Yeah. And so you've got this situation where you've got two galaxies are actually colliding with each other.
Roy, can you just boost the saturation on that a little bit?
You're doing it remotely though, right? Or you are bringing
yeah,
the
okay, never
objects
mind.
over.
It just because there's some nice color in that. And
I can try boosting the saturation. Let's see what it does. Yeah, let me save these off and I'll show you that one.
Okay.
So just to sort of show people here, here while he's doing that, I'll sort of show people where it is. So again, this is still we're in the Big Dipper still, but now we're just below the handle of the Big Dipper. So here's where M101 was that Linda was showing, and here's where M51 is, the Whirlpool Galaxy. And as I said, it's got two objects as part of it, the main galaxy and then the smaller galaxy. And there's this tidal tail. I'll go back to Roy's image. God, that image is so good. You've got this tidal tail that's connecting. So can you zoom in a bit? Can you give me enhance and magnify?
Yeah, enhance and magnify. Let me share the
zoom
other
in
one.
and enhance.
Let me give you the one that's doing.
A couple people are asking what your camera is. A couple people are asking you what your telescope is. So
there you go.
So with the exposure, it's a 3-minute exposure. You've got a brand new camera that has megapixels, I believe.
Yeah, it's a 62 megapixel camera.
Wow. And look at the colors. And so it's just a straight up color camera.
Yep.
Wow. That's stunning.
I really need to change my camera.
And looks like you got a satellite trail going through.
Could be.
Yeah. Starlink.
Yeah, I didn't think it was going to be that good of an image with 3 minutes.
Yeah.
That's
more, please. More, please. So, have you tried the Ring Nebula? Let's see your Ring Nebula.
I have not. I will.
Yeah. What would be good for that machine? The Iris. You should try the Iris Nebula as well.
Oh, that would be good, yeah.
Yeah.
Okay, I can do the Iris first.
Yeah, let's try the Iris.
So just as a point of comparison, this was mine from last week, and this is 2 minutes with a monochrome 8300, and you can see just the difference in noise. His is far less noisy than mine is.
Yeah. Yeah, and so, but I mean, like, the telescope isn't any faster, right?
This is a F, with the reducer I have on it, it's an f6.4.
Okay. Yeah. Yeah, I am suitably impressed. That is a stunning image for a 3-minute exposure. That's crazy. We have arrived at real-time astronomy. And Linda, let me know when you got another image.
Yeah, I've been working on a couple things. We had some trees in the way, but I've got a dumbbell coming.
Is that the dumbbell?
Yeah, this is just the plate solve image. I've got a longer exposure running.
Okay, all right. So
my thing is going to be that the bandwidth I'm taking up now to get all these images. That's what's going to slow me down.
Yeah, well, can you convert them to JPEG or something on? But I guess you want to keep them in a FITS file, right?
Yeah, I need them a fit so I can bring them locally to process them.
Yeah. So the dumbbell.
I can try installing all the software remotely to process them, so then I just download the JPEG.
Yeah.
But I haven't done that yet.
Gotta turn guiding back on.
So
Fraser, I want a color camera.
I love. Well, it's funny because I mean, at the end of the day, the color camera is, it's limited if you're going to try and use filters, if you're going to try and do separate exposures. But if you just want to quickly show people the images of the night sky, the color camera is the machine. Good night, Nancy. And so that's why I was pushing Dustin when he set up this telescope, the RASA, to go color. And it's got but now I'm going to ask him if we can install this camera, please. It's better.
What kind do you have on your phrase?
I don't know.
Oh, okay.
Yeah.
I've got over here the Centaurus A, the active galaxy in Centaurus.
Oh, great.
NGC 5128, also taken last night.
Yep.
Oh, nice.
So it's really, last night was okay. Yeah, not bad. It was cloudy for the past few weeks, but last night was okay. So I got few. And this is a 2-minute exposure from a city light pollution area. So it's not bad.
Yeah.
Yeah.
I don't know if we can't see that yet. Let me see.
I have a processed image of that.
Of Centaurus A? Oh, it should be up actually. Well, it's 10 degrees above the horizon, so it's fairly low.
I've got a dumbbell for you.
Oh, great. Okay. I'm ready. Oh, great.
So this is 60 seconds of luminance on the dumbbell.
Right.
And you can actually start to get a hint. When you look at it visually, all you see is this apple core shaped part.
Mm-hmm.
But we can actually see some of the outer faint edge here coming in.
Yeah. Yeah, no, that's great. And
you,
so the
you don't get
dumbbell
to
is
see that.
another. So before we saw the Ring Nebula, and the Dumbbell Nebula is another planetary nebula. So another nebula like another star like the sun at the end of its life, and it'll give off all of these layers into space.
Right. So with the ring, it probably looks a lot like the dumbbell, but we're looking at the ring from the top and the dumbbell from the side.
Yeah, it's funny to think that each one of these is a sphere. And so you're seeing, and then as the star dies, it's got these powerful magnetic fields, and then it channels some of the material out through these magnetic fields. And so what looks like just some flat object that we're seeing through space, we're seeing a three-dimensional object. We're just seeing it because it's translucent. We're seeing it through the side. So Christopher Trispec asks, so in the image of the two joining galaxies, how on earth would we even notice that happening when the Milky Way merges with Andromeda? I heard we wouldn't even notice if we were around then. Yeah, when Andromeda and the Milky Way merge, we on planet Earth will feel almost nothing. Andromeda will be a much bigger, brighter galaxy in the sky. It'll look like a second Milky Way as it's really colliding with us. But the chances of any stars actually impacting the sun, disrupting the solar system are almost zero. So it would be theoretically happening to our galaxy, but we wouldn't really experience anything.
I have up. This is a processed version of the Centaurus A that.
Oh, great.
That Shah just showed us.
Oh, wonderful! That's amazing.
And this was taken in Chile through the Star Shadows Remote Observatory through CTIO.
Oh,
and,
okay.
It's not mine, but it's data that I have access to, and so I'm just showing So Shah had a 2-minute image, and was a.
Yeah, sort of.
I don't know exactly how many, but it was many hours.
Yeah. And so you can see that's the difference. I mean, with these star parties, we're just trying to bring the images up as quickly as we can to show people just sort of how this works and what kinds of stuff we can do. in the night sky. But each one of these objects could be hours, tens of hours, sometimes even hundreds of hours of constant observing to build up a very complicated image.
M82's up.
Oh, great. Everyone check for supernovae.
M82 is an object that I was trying to find earlier, but I could almost see it between the tree branches.
Yeah. But M81, so you can't get an M81 in the same field of view.
No, I could if I really got them right on the edge.
Right, if you like sort of focused on, if you manually put in a spot in between the two of them.
Right, they would be right at the edge of the frame on both of them.
Yeah. And so I think M81 and M82 are gravitationally bound to each other.
Yeah, there's tidal tails.
Yeah, there's tidal tails connecting the two of them. Yeah, so they have stripped away the hydrogen gas from all three galaxies, and you've got these tidal tails that are connected out between all of them.
I'll get an M81 as well.
That'd be great.
While he's doing that, I've got the dumbbell in oxygen, and it almost looks like a totally different object.
Yeah. And so, Linda's using narrowband filters that essentially block out all of the light except for the light that is being generated by a certain kind of atom that's being excited. So what was the previous one was luminance, right?
Yeah.
Okay.
The first one was luminance. This is O3, so doubly ionized oxygen.
Right. And then this one is oxygen. And so, someone's
This is a
banned.
fabulous object in O3, and it's
really bright in oxygen.
Yeah.
That's what gives it that blue color in
So are you
photos.
gonna stack them up so we can see a color image?
I can
colorer image?
I'll give it a try. Let me grab an H alpha frame.
Yeah.
Yeah, I found with the Veil Nebula that I was taking that it's really rich in the oxygen as well.
Yeah. And so is that a problem? Like when you're using these full color cameras, I mean, the nice thing about doing these separate filters is you can tweak each filter to build up the image that you want, right? You've got total control over the 3 color channels that you're working with. But in this case, you've just got whatever you're seeing through the color sensor, right?
Yeah, well, I can tweak the red, green, and blue on this.
Yeah.
I had a good friend of mine who said, "Friends don't let friends buy color CCDs."
Yeah.
I told myself I was never going to, but
I will never not.
Well, for something
always,
like this,
you've got to know. Fraser always wants color.
Yeah.
Yeah.
And this is for something like this is perfect.
Honestly, when I was thinking of buying this camera, there was in the back of my head going, Fraser would like this.
Yeah. Yeah. Well, I don't know what kind of monster I've become then. The fact that I'm actually starting to influence your gear choices, which friends wouldn't let friends buy, but boy, they're good for star parties.
You already made me change my mount, so
Did I? Oh, okay.
Have
you ordered a Paramount? Is that what you're saying?
No. I went back 7 years ago when we first started. I had an old mount that just didn't cut it for the star parties, and I finally said, "Screw it! I'm getting an astrophysics mount."
Yeah. Well, that just makes sense. You can't blame that on me. That's
Right. You were my catalyst.
Right. Yeah. Go on, Stuart. Faster. Yeah.
So when someone asks me why I'm moving from DC out to some property in a dark sky and building an observatory, I'm going to say it's Fraser's fault, so I could help him.
Yeah, exactly. Yeah, feel free to blame me. Yeah, totally. Bernie Gojira is asking, now I wonder with the knowledge of what kinds of elements are present, what kinds of planets would form in the nebula. So that nebula that Linda is gathering is a planetary nebula, so it's a dead star, and so you're not going to get any planets in this nebula. You're looking for a star-forming nebula, which there aren't any good ones up right now, although maybe Roy's going to try and get an image of the iris.
It's coming up.
Good, yeah. So no, this is the wrong kind of nebula. This is the death nebula, not the birth nebula.
This would be a nice reflection.
Yeah, come back in January and we can show you the Orion Nebula.
Yeah, yeah. Well, no, I mean, just in another couple of months, we'll have all of the summer nebulae up, right? So we'll have the Lagoon and the Eagle Nebula with the Pillars of Creation and the Swan Lagoon are the same thing. The
Swan's M17.
The Trifid. So lots of good nebula in the core of the galaxy, but right now they're not happening.
All right, it's up.
There you go.
Oh, cool.
3 minutes.
That's perfect. Larry's asking if I went to Atacama. No, that was a Paul thing, not me. Can you zoom and enhance one notch? There you go. Yeah. So what you're seeing here is this is a nebula, but a dark nebula. And so all of this dust that's around it, I think, has been blown off by the star, or is the nebula that the star is forming inside of. But its powerful radiation is reflecting off of the material that's really close to it. And so the nebula itself isn't giving off light yet, but eventually it'll get to a point where it will actually start to give off light. But it's absolutely incredible. So this is called a reflection nebula. And what I love is that these are they look great in color cameras. They're the
I'm
right.
liking the camera.
They look pretty mediocre in some of the more monochrome stuff, but in the color cameras they just look fabulous. Yeah, there you go. Thad is saying, Eagle M16, Swan M17, Trifid M20, and Lagoon M8. So we will see.
Where is Thad?
He's in the chat because he wasn't able to get his camera and microphone working. So Scott Whedon is asking, what are the M numbers? So those are the Messier numbers. So there was an astronomer named Charles Messier who back in the 1700s was a comet hunter. And so every night he would take his telescope and he would scan the skies looking for comets. And the problem was he kept seeing these same little blurry fuzzy objects in the sky. And so he started numbering them. And so there's a total of 115 objects that he found. Is that right? 15?
110.
110, right. But there's some missing numbers, and there's a bunch of fairly bright objects that he missed. So it's sort of weird that the way he did this. And so he would use that as a guide to go, oh, okay, wait, I found a comet. No, that's just M13, Messier's 13th object. And we still use them to this day.
To be fair, I was looking at smudges in a telescope, so.
I have the dumbbell and hydrogen alpha, which looks different from the oxygen.
Yeah.
And as soon as the image syncs over, I'll try to put them together in PixInsight.
That's great. That'd be great to see the three together.
You put the narrowband together, and I'm going to take a color.
Cool. Yeah, I'll do an HOO combination.
That's terrific.
I got the Comet Pan-STAR over here for comparison from last night.
Oh, great.
Share the screen, yeah. So
on the left is the Pan-STAR, and on the right is the lemon. So you can actually see. So it's brighter. It's much better.
Yeah, much better. You can actually see the tail. This is just a single 2-minute image. So I haven't stacked or anything. So you can actually see the tail coming up on the upper left compared to Pan-STAR.
Hey, Nightbot is saying that we won the Parsec Award in Twitch.
Award?
Did we? Not for the Star Party. I think we won for Astronomy Cast. Like, wait a minute, what? We didn't submit the Star Party to the Astronomy Cast. Hey, Gibson Picks just rated with a party of 29. Of course, we owe a huge debt of gratitude to Gibson Picks and Oceanside Photo and Telescope for letting us use using his wonderful telescope, although we weren't able to make it happen tonight.
Well, if they want to send me any gear, they can do that too.
Well, but at this point, I think all it is that I'm going to be bugging Dustin about this wonderful camera that you're using.
I've already bought them out the last 2 months.
Oh, you bought them? Did you get it from OPT?
Yeah.
Yeah. Okay. Yeah, that's incredible.
I'm on the OPT website looking to see how much that.
Don't do it, man. Don't do it.
You
Well, I'm
don't.
sure-
You don't
You're
want
not gonna
to.
like it.
Yeah. You don't even want to know.
Ignorance is bliss.
Yeah.
I don't know.
Although for what the camera provides, it's not unreasonably priced. But
I wouldn't need the full frame. I just would want the 1600.
Yeah.
The 1600 is a good camera.
Yeah.
the worst part is you get the full frame camera, and now you've got to replace all your filters, and then it gets really expensive.
Well, I would do the color. That's the thing. So I would do the color for the VSP. With the whole point of why I
Yeah.
would.
Yeah.
The only thing with the 1600s is it's only 12-bit, not 16-bit.
Yeah.
But I don't really know what the visual difference would be on that.
Be fast.
Yeah. All right, we're sort of reaching the end of our hour, so if anyone's got, you guys are going to try and put together this combined color image of the dumbbell versus.
Let's do a dumbbell.
Yeah, a dumbbell off.
face off.
Yeah, a dumbbell off.
Yeah, I've got to take another exposure. For some reason, it didn't save.
No.
But I am.
Oh, I love this.
Yes, it did. I just didn't recognize it.
Oh, okay, all right.
I've got
One of these.
one set up before.
Okay, yeah, I'm on your iris right now, so go ahead and
All right, let me
dump another one in
get
there.
the next one here. Where is it? Could have swore I downloaded it.
Amanda's saying just 1 hour. Yeah, Amanda, sorry. We try to keep it to around an hour, a little over an hour. Depends on it depends on how badly we're messing up the technology. But we've gotten a lot smoother now.
Linda over there.
Yeah.
I mean, Shaw just had his morning cup of coffee.
It's breakfast. Yeah, no problem. It's daytime for him.
I'm getting sunburn.
Yeah. Well, what's the temperature there?
Daytime is about 35 degrees Celsius. So it's really.
Oh, that's not right.
Yeah, it's not right.
That's just wrong.
Yeah. Although summer hasn't arrived here on the west coast of Canada. We're still having just cold days. I haven't even switched to shorts yet. It's sad. In June, we're still it's just pouring rain every single day. We call this January when it gets cold. Oh, that's beautiful.
It's M81.
Yeah. So that's the other half of that pair, M81.
Mm-hmm.
Trying to find my dumbbell. It's not showing up here.
That's a sweet spot. Off the Zach board is asking how often do we do these? We do them once a week on my YouTube channel, and then they simulcast them here on Twitch. So if you subscribe here to CosmoQuest on Twitch, then you'll see all of the various shows that we do across our network. And they're all simulcast on Twitch. So all the stuff that I do on YouTube, Astronomy Cast, Weekly Space Hangout, they all show up here on Twitch as well.
I have the combined.
Ooh, I want to see.
Oh, yeah.
M27.
That looks good.
Oh, terrific.
And that's just 2 frames. That's
using
the
HLO
magic in
pod?
there, Ben.
That's the luminance and the oxygen? Or is that the
No,
high?
this is 3 minutes of hydrogen, 1 exposure, and 2 minutes of oxygen, 1 exposure.
That's the HOO power?
Yeah.
Oh,
yeah.
that's great.
And that's the magic of narrowband.
Yeah.
I have to retake mine because it didn't. So it's going to be about 5 minutes.
Oh, people are saying follow, subscribe on YouTube. I see. I don't know the Twitch lingo.
Oh, I just noticed something on my setup here. I have a reflection.
Bad Panda Bear is asking, is the VSP going to go on hiatus? Yeah, my plan is that I'm going to put the VSP on hiatus, but what I'm probably going to do is just run experiments. So the reason we do the shows on hiatus is because Twitch streamers will understand this, that you just trying to find your way to high-speed internet every couple of days is taxing on the brain. And so we typically take, you're going after the Pelican Nebula. We take 2 months off every summer, and we sort of put all of our shows on hiatus. So I'm going to probably put the Star Party as well on hiatus, and then we'll come back in September.
Cool.
Just because it's exhausting. So have you? No, that's right. I was going to ask if you've tried, but you haven't tried anything. This is you taking this on its first voyage. Yeah.
Oh, his camera.
Yeah. So Linda's going after.
Finding things that are still in the trees.
Linda's going after tree objects. Yeah.
Yeah. Let me show you.
Beth, you want another intro for everybody?
Do the veil.
Yeah, the veil's going to be up.
Veil should be up for you.
Yeah.
Yeah. Let's see. Now it's lower than what I was going after.
Yeah.
But we'll try.
Yeah. So Twitch, I tend to do my experiments on Twitch. And so I want to set up a bunch of new technology. I want to do some more planetary work. We want to get that Uranus that everyone's always asking for. Commentary stuff. I would love to be able to try and capture some satellites, the International Space Station and stuff live. So I'm going to try and work with Dustin and see if we can figure out how to solve some of these technologies. Okay. Well, Roy, did you get your dumbbell?
It's just finished exposing. Now I've got to download it.
Okay. Well, as soon as you finish doing your download, then I think we'll shut this down. So.
Yeah, the veil is behind the tree still.
Yeah. Cosmic Quest says Fraser phrasing. I say the word Uranus in whichever way is the most hilarious way. So it's so if I'm trying to say it ironically, then I'll say Uranus, or if I'm trying to say it pedantically, then it'll be Uranus, and if I'm trying to say it filthily, then it's Uranus. So. It really is a very flexible planet name.
While we're waiting for that, since there's no other images up, I'll show you the image that I showed you guys before this. The veil that I did.
Yeah.
I really like this. This is not this color camera. This is the narrow band.
Oh.
That's Hubble palette?
That's Hubble, yeah.
Mm-hmm.
That's
I didn't know there was much
so
sulfur
great.
in there.
No, there's not. It surprised me.
Yeah, so most times I've seen it done in HOO palette. You might try that.
Yeah.
Not do the sulfur.
I have a club member that did narrowband on the Eastern Veil last year, and he did 2 versions, one HOO and one HSO, and both of them were spectacular. But there is sulfur there, but there's not a lot compared to the others.
Yeah.
This
is one
up on Astroband.
So I just want
to with the links to the 3 FITS files for this, so if anybody wants to play with it.
Oh, great. Yeah. So you guys have been dropping images into the directory.
I haven't yet. I will.
Okay. Yeah. If you can.
I got to rename them some.
Yeah. So just to show people this is just an incredible complex. So it's called the Veil Nebula, and what it is actually it's a huge supernova remnant that blew up many thousands of years ago, and you're seeing just the expanding cloud of gas and dust. And the specific image here that Roy's got up, this is the chunk that's up here with this bright star, 52 Sig, which is in the East Veil. I think that's the Witch's Broom, right? Yeah, and so it's just so it's such a huge object that people can't even take an image in one picture. They have to take multiple images to try and capture the whole thing. And so Roy's entire field of view, if you compare it, so here's this chunk is that.
Linda could probably get a lot more of it with her 80.
Even in mine, I can only get one side or the other.
Yeah.
If I use my refractor, I still have to take a mosaic of it.
Yeah,
I mean, I need 4 panes.
Yeah. So just a reminder that all of the pictures that everybody was taking tonight, they're going to drop into the Google Drive photo, both the processed JPEG or the FITS images or video, if that's what Shaw has. So if you want to try and process your own versions from these pictures, go ahead and do it, or put them as your background. All we ask is that you only use them for personal use. Don't sell them to Astronomy Magazine for their cover.
If they can make a sale out of one of my images to Astronomy Magazine.
One of your 3-minute images, one of your 3-minute monochrome images to Astronomy Magazine.
Non-calibrated.
Yeah, fill your boots.
Knock yourself out.
Yeah.
Hey, Fraser, can you pull back up that other dumbbell that you had up?
Oh yeah. Well, does Linda have it on her screen? No, Linda's.
I can put it up on my screen.
So we can compare.
Just so people have that in their mind.
Yeah. All right.
Look at the color version.
At least if I can find. Oh, I'm sharing the other screen.
Yeah, you're sharing your clouds, I think.
The trees.
Yeah.
There we go.
It's amazing how similar these are going to be.
Oh wow. Okay. All right. So that's 2 colors: hydrogen alpha and oxygen. Okay.
Yep.
All right. We're ready, and we're going to switch to yours, Roy.
Yep.
Wow.
Yeah.
And then that's actual color.
And that's the actual. So that if you saw that with your eyeball, that's what it would look like.
Yeah. Mm-hmm. So her narrow band with just the hydrogen and 2 oxygen it's very close. It's the stars that are different.
Yeah, that's kind of amazing. Interesting. Fantastic. All right. Well, everybody, thank you so much for joining us for this week's Virtual Star Party. I want to thank the hardworking mods over on Twitch, on CosmoQuest channel, who just got deluged with 8,000 subscribers. I don't even know who rated the chat. I don't even understand Twitch. So, the fact that I was able to get a sense of what was going on, you really... you've handled that like champions. So thanks everybody for joining in. Thanks to the astronomers for sharing their view of the night sky. I mean, this is a volunteer effort, and we really appreciate the work that you do and taking time out of your schedule and even staying up late. Although you're astronomers, so you can handle it. And then, except for Shaw drinking his coffee in the morning, in the heat of the day, in the heat of the Malaysian sun. Yeah. So we'll be back next week, same time, different telescopes, different objects. We'll see you next week, everybody. Thank you.
Bye.